In this module, we'll follow a verifiable credentials journey through a EUDI wallet. From issuance, storage, and presentation, through verification, revocation, and refresh, you'll see how relying parties build lifecycle-aware trust for digital onboarding and KYC. You've already designed a compliant onboarding journey. You know the regulations, the actors, the KYC needs, and how they map into your target architecture and happy path flow. Now we'll focus on why that flow can be trusted. We'll unpack how credentials are issued, signed, and bound to a holder, how the relying party validates issuer trust, checks status and revocation, and prevents replay, so KYC decisions stay reliable over time. In a wallet-based model, you're no longer just checking documents, you're checking trust. Every credential has to pass a chain of questions. Is the data correctly signed? Do we trust the issuer's governance and processes? Is the credential still valid, or has it been revoked? Is it bound to this specific holder and device? And is the presentation recent enough? Only when all these layers are satisfied should a KYC decision rely on that evidence. A credential isn't created once and forgotten. First, an issuer verifies the person and signs a credential. That signed object is what others later rely on. Then the holder's wallet keeps it secure and ready to use. When needed, the holder selectively presents claims, and the relying party verifies signature and status. Over time, credentials can expire, be revoked, suspended, or refreshed, so ongoing lifecycle checks are essential for KYC trust. Think of issuance as getting a passport, and presentation as deciding which page to show at a border. Issuance creates and signs the credential into your wallet. Presentation selectively reveals claims, which the relying party still has to validate before accepting them as KYC evidence. Issuance starts when the holder asks an authorized issuer for a credential. The issuer first authenticates the person and verifies the underlying data. Once satisfied, it creates a digital credential and signs it with its private key, binding the data to its trusted identity. That signed credential is stored in the holder's wallet, together with metadata like issuer, dates, and status. Later, relying parties use this information to judge assurance before accepting it for KYC. During presentation, the relying party asks the wallet for exactly what it needs and why. The request includes the purpose, audience, and transaction context. The holder reviews this, then consents to share only the minimum attributes. The wallet assembles a signed, verifiable presentation from one or more credentials. The verifier checks nonce, audience, signature, issuer, status, and expiry, then forwards trusted attributes into the KYC engine. Verification is a pipeline, not a single cryptographic thumbs up. First, the verifier confirms the presentation really responds to this relying party's challenge and hasn't been replayed or tampered with. Then it inspects the embedded credential. Is the signature valid? The schema correct? The issuer who they claim to be? And the credential still within validity? Finally come status and policy checks. Has it been revoked or suspended? And does it satisfy KYC and risk rules? Credentials aren't a one-time decision. They move through several states, and your verifier needs clear rules for each. If a credential is revoked, treat it as a hard stop. Deny access and log why. Suspended means pause and investigate until the issuer lifts or confirms the hold. Expired usually triggers a refresh or reissuance step. And when status is unknown or unreachable, your policy must decide: fail closed, retry, or route to manual review. When you design status checking, start by deciding which sources you trust: issuer APIs, status lists, registries, or broader trust networks. Next, define a verification service that can call those sources, validate responses, and apply policy. Introduce a cache with clear TTLs so you balance freshness, availability, and privacy. Plan explicit error handling and fallback paths. Finally, log outcomes and evidence for audits while minimizing personal data in those logs. When a credential is presented, the real question is, who stands behind it and who stands behind them? First, the relying party checks the issuer's identity using keys, certificates, or trust registries. Then it confirms the issuer is actually allowed to make these specific claims. Next, it validates the credential's signature and the status of the issuer's keys. Finally, it maps the issuer's and credential's assurance levels to its own KYC policy before accepting or rejecting. A credential being cryptographically valid doesn't mean you can use it for KYC. You still have to ask, does this credential meet our policy? Check that its type, schema, dates, and assurance level match what your compliance matrix expects. Then confirm the claims actually cover required attributes like legal name, birth date, address, or nationality. Finally, apply jurisdiction, product, and risk rules and log both the decision and your reasoning for audit evidence. Think about a passport check at a border. The document alone is not enough. The officer also checks that your face matches the photo. Holder binding is the digital version of that. The wallet proves it controls the cryptographic keys linked to the credential, often protected by biometrics, PINs, or device-bound keys. Verifiers must choose a binding method that matches their risk. Lighter checks for low stakes. Stronger binding for high-risk onboarding. Replay protection makes each presentation a one-time ticket, valid only for a specific transaction. The verifier sends a fresh nonce and a clear audience and client identifier. The wallet signs these along with the timestamp, expiry, and transaction ID. When the response returns, the verifier checks the signature, audience, nonce, and freshness. If anything is stale, reused, or mismatched, the presentation is rejected instead of being silently accepted. Trust validation is the bridge between a wallet claim and real KYC evidence. You separate issuance from presentation, then verify validity, issuer trust, holder binding, and lifecycle events like revocation or expiry. In the next step, you'll design what happens when any of those checks fail and humans need to step in.